The computer network student must know about how to do the subnetting. That's very essential. So here I'm going to take two examples for you. The first example, here we are going to split this network into 4 subnet. That is the first example. Before that, you need to understand what is a IP of it. Okay, so here this is a IP 192.168.10.1. this is called as a IP address. You see this IP address which splitted into 4 dots, 192.168.10.1. okay, so this is called as a subnet mask, which belongs to what type of category of network is this. So the /22, which means this is a class C IP address. Okay, so what is what we want to do here? We are going to split this this network into 4 subnet. For example, you have one major network. This major network, you are going to split it out 4 subnetwork. Okay, so you have one network IP. So this is IP address of 192.168.10.1/24. this is your IP. You are going to split this IP into the 4 subnet. So that is your task. Okay, so before that, you need to understand how the IP addresses are actually understood by the system. Okay, here you see the 192, it's actually the binary number. Okay, you see that 192, it's a binary number. So this is the actual binary number of 192. Okay, you see that this is a binary number of 192. Okay, okay, so 192.168.10.1. okay, so 10.0, I guess. Yeah, 10.0. okay, so this is a 192. okay, this is a 192. Next, 168. so what is a binary number for 168? So here you see 168. So this is a binary number for 168. Binary number for 168. Next, 10. Okay, 10. Sorry, 10. Sorry. 10. 1010. so 000010, sorry, 1010. so this is a 4 1 2 3 4 1 2 3 4. so this is the IP. okay, so right now you are going to understood this like this way. Okay, 192.168.1.0 only we classify. Okay, so remaining are saying 192.168.1, so 10 remaining are same. Okay, so right now we are going to change the factors here. Okay, so we are going to change the factor here. Okay, so the first 3 factors are same to the entire 4 subnets. The last one only changed. We are going to get changed here. Okay, so this is a IP so which represented by the binary digits. Okay, we cannot remember the binary digits as a human, so that's why we are going to convert it into the decimal numbers. Okay, so First we are going to understand this is, so this is the first one. So first we are going to, so 2 to the power of 8 minus 2, so this is a 2 to the power of minus 2, it's a 254. Okay, sorry, 256, sir. 2 to the power of 8, 2 to the power of 8, it's equal to 256 minus 2. So why we are going to minus 2, that is 1, it's for your network ID, which means your router IP. Another one is your broadcast IP, which means first IP and last IP. For example, what is the first IP of this network? First IP of this network is this, so this is the first IP. Okay, second IP, so this is next one, 00000001, so this is a second IP. So just like that, so this is the last IP. What is the last IP? So which one is the last IP? 192.168.10. which one is the last IP? 1111. So this is a last IP, and here this is a before the last one IP. So this is called as a network IP, which means your default gateway. This is a broadcast IP. So you will learn about it later classes. What does it mean by network IP? What does it mean by broadcast IP? So here we are going to erase, we are going to minus these two. Why? Because this is not, you cannot provide these two IPs for devices. So this is for your router, this is for your broadcast. Okay, so here you see 192.1, okay, 00000000, so 0010, so the next one. Okay, so just like that it will go up to the final one. Okay, so the list go here one by one. Okay, so next one, so right now we need to split it into the 4 subnets. That's what we need to do. So here this is a formula, 2 to the power of n greater than or equal to the 4. So which number you are going to provide, a number n, so it should be greater than or equal to the 4. So 2 to the power of 2, it's a 4. 2 to the power of 2, it's a 4. So here n equaled 2. So 24 plus 2, so your subnet mask, it's a 26. So here we are going to use a subnet mask, new subnet mask 26. So here we are going to use a new subnet mask 26. Okay, so this is our subnet mask of the 26. Okay, here how do you know this 26? What is mean by 26? It's very simple. Here you see the total, it's a 8 bits, totally 32 bits. Okay, 8 plus 8 plus 8 plus 8 plus 8 equal to 32. Okay, so this is a 32. So what is mean by 26? Which means that the first 26 bits are 1, remaining are 0. You see that first 26 bits are 1, remaining are 0. Okay, so this is it. Okay, so first 26 bits are 1, remaining are 0. So in this case you see that in a subnet mask, so this is actually your IP. Okay, you understand, this is your IP, don't involve this. Here you see that your subnet mask 1 2 3 4 5 6 7 8, so this is a 255. Okay, 1 2 3 4 5 6 7 8, so this is a 255. Next one 1 2 3 4 5 6 7 8, this is a This is a 255. So 8 plus 8 plus 8, 24. So remaining 2 bits, 1 2 3 4 5 6 7 8. Okay, sorry 1 2 1 2 3 4 5 6 7 8. So this is, you need to figure out what is the number is this. Okay, so go to the calculator, go to the binary section. 1 1 2 3 4 5 6 7 8. So what is the number? 192. 192. So this is your subnet mask. This is your subnet mask. You are going to use it here. This is your subnet mask. You are going to use it here. So this is the way you are going to calculate. You must need to calculate the subnet mask. Okay, so right now you are going to minus 256 to 192 64. So here you have a 64 host, which means you can create a 64 IP address. Okay, why you are going to minus it into the 255? So here you see that, you see what is a value for 1111 here. 2 3 1 2 3 4 5 6 7 8. So 255. Okay, so right now you are going to minus it. You are going to minus 256 minus 192. It's a 64. So each subnet increases by 64 in the last octet. Okay, you see, you are going to increase number 64 in this case. 64 in this case. So 0. So this is the first network ID of yours. Second network ID of yours, 64. 64 64. You can split it out. So first network ID 192.160.10.0 to 62. Why 0 and the first IP and the last IP, it's you are going to delete it. Okay, the first IP for your network IP, last IP for your broadcast IP. So this is a usable range. So you can assign this range of IP address to your device. Okay, to your device. So you can assign it to your system. So this is a broadcast IP. You see, this is the broadcast IP of your system. So I will teach you what is a broadcast IP in a later classes of the computer network layer, when I teach you to computer network layer. Okay, so this is it. So the calculate the usable host of first subnet. So 2 to the power of 6, 2 bits. Now you are going to, after borrow 2 bits, we have a 6 bits left in the host. So 2 to the power of 6 minus 2, 64 minus 2, it's a 62 host we have. Okay, so this is the reason why we are going to minus 2. This is the reason, network ID and a broadcast ID, which means all zeros is the network ID, all 1 is a broadcast ID. Okay, so this is the usable range of this. Okay, this is your network. This is a remaining host IP of yours. Okay, next example. So this is a VLSM model. So this is a variable length subnet masking. In a previous case, we are split up into the class C IP. So right now we are go with the CIDR model. Okay, which means that we don't use any classes. We are going to use the entire IP as a network. Okay, for example. So what is the question here? We have a network. This is our network. You need to split this network into 3 subnet. But the first subnet you are going to use a 50 host. Second subnet you are going to use a 25 host. Third subnet you are going to use a 10 host. That is your question. So you are going to split it up into the 3 networks. So So we need to divide the subnet mask 24 into the 3 major subnet. Okay, so first we just need to know about it, how to do it. So here, this is our question. We are going to split it into the 3 network. First network, it take a 50. Second network, it must have a 25 devices, 25 IP. Third network, we need to assign 10 IP. So what is a easy rule? Always start with the largest subnet first. So here you must go with the largest one to avoid overlapping. What is mean by overlapping? If we are going to provide two devices the same IP, that is called as overlapping. So there is no two devices in the same network never have a same IP. That's a rule. Okay, so here we need to assign 50 host for subnet A. Okay, so this is where 50, it must greater than or equal to 2, 2 to the power of h minus 2 greater than or equal to 50. So what is 2 to the power of 6? 2 to the power of 6, it must be the 62. 2 to the power of 6, 2 to the power of 6 is a 62. So it is greater than or equal to the 50. You can take 7, but it's too large, so it is a nearest large one. That's why you take a 62. So that's why you take a 6. So only 12 IPs are not usable here. So here you are going to take a host bits for 6 host bits, which means that you are going to use a 32 minus 6. What it mean? What this part mean? You go there 6 bits for host, remaining bits for network. You see there, I'm going to take this here. So the 6 bits, so from the last one, what is mean? Minus 6. Okay, 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, so 1 2 3 4 5 6. This 6 bits represent host. Remaining bits from here to there, remaining bits represent host. Okay, so that's it mean here. So it gives you number 26. Okay, what is this? This is a /26. How do you know this is a /26? 32 minus 6 is a /26. So here you are going to implement it into here. What is the number? 192. So you see that 192. Okay, how many block sizes? 256 minus 192, 64, but minus 2. Okay, 62 host you can connect this network. Okay, the first block IP is a 192.168.1.0, and the first IP is this. Last broadcast IP is at 63. Remaining from 192.168.1.1, 192.168 is 1.62 up to here you can assign it. So this is a 62 usable host, it's available. 12 IPs are not used. Okay, remaining, so you can use it, but we need one. For example, in our network which contain 50 devices, so remaining 12 IPs you have. Okay, right, next one. So similar like that, 25 host, so similar 2 to the power of h. So here you are going to provide number 5. So 30, it's your number, so same values or same way you are going to calculate it. So number /27. What is mean by /27? So first 27 bits are 1, remaining bits are 0. Okay, first 27 bits are here, 1, okay, 1 2 3 4 5 6 7 8. Okay, so that's it. So 224, you see that 224 is here, 224. So 256 minus 224 is a 32. So you can connect here up to 32 devices, but we need only 25 hosts. Okay, so it's greater than it. Okay, so here the first IP, it's this is a network IP. What is mean by network IP? You are going to provide this IP for your router. This is a broadcast IP, so you minus it. So this is a usable IP for your entire network. So next one, you need to connect a 10 host. So the same way, 2 to the power of h, h is a 4, it's a 2 to the power of 4, it's a 14, but we need only 10 devices. You cannot take 2 to the power of 3. Why? Because this is a 8. Okay, you need one more IP address. Okay, that's why you go with the 2 to the power of 3. Okay, so the same way, /28, this is a subnet mask, so you can connect up to 16 devices. So first IP, broadcast IP, and everything else. Okay, here in this case, this is the entire network summarize of the subnet. The class A from 1.0 to 1.63. so this is a usable IP range of it. This is a network IP, this is a broadcast IP of your entire network. So here one more detail of the next available addresses space is that these are all the available address 1112. So this is the network IP, because the last IP is a broadcast IP 111.111, but we have a remaining IP addresses available up to 111 to 255. Okay, we can connect another one network within this. Okay, so this is it. So this is a way you need to calculate the subnet mask. I hope you understood. Okay, see you.